OSPF can load balance across equal cost paths, and by default that's what EIGRP does as well. However, we can configure unequal cost load balancing. It's not on by default. Let me prove it to you. From the perspective of R2, let's take a look at the IP routing table. Let's do a show IP route, and let's take as an example the loopback interface of router R1. We see that we just have one path to it, and it's via 192.168.1.1, which is via router R3. We're preferring to go over this link, which I've configured now as a 10 meg link, and then go over this 100 meg link instead of going over this serial link. EIGRP probably knows about both paths. In its topology table, it can go from R2 to R3 to R1, or it can go directly from R2 to R1. Let's just make sure of that. Let's do a show IP EIGRP topology. And sure enough, we have two paths to get to 1.1.1.1. One path is via R3. The other path is direct to R1. Why are we going via R3? Because the feasible distance is less than going directly to R1. And that's why this path via R3 is injected into the IP routing table, because it has a feasible distance of a little over 390,000, while the path to R1 has a feasible distance of over 2.3 million. However, with EIGRP, we can say that we want to load balance across these paths even though they have an unequal cost. Here's how we do it. We use the variance command. The variance is a factor. It's a factor that establishes an acceptable range of feasible distances. Here's the way to look at it. Take your best feasible distance, in this case 390,123, and we ask what number could I multiply that by to establish my maximum acceptable feasible distance. Let's bring up a calculator to better illustrate this. Let's put in 390,123. Let's say we had a variance of 2. I would say 390,123 times 2. And this would be my maximum acceptable feasible distance. It's a little over 780,000. Based on that, would I be load balancing across this WAN link? No, because 2.3 million is still a lot more than 780,000. So here's what we do. If I want to load balance across this link, here's the easy way to calculate the variance. We're going to take the worst acceptable feasible distance, divide by the best feasible distance, and then round up. In our case, we'll take 2,304,357, and I'm going to divide by my best feasible distance, which is 390,123, and that gives me 5.9 roughly. We have to use an integer when we specify variance, and 5 would not be enough. We have to round up. We have to say we want a variance of 6. So let's go into router configuration mode on R2. Let's say router EIGRP 100, and we'll say variance 6 based on our calculation. Once we do that, we should be able to load balance across those unequal cost paths. So in other words, not only will the EIGRP topology table know about those two routes, our IP routing table will know about those two routes, and it will be using those two routes. Let's take a look. Let's do a show IP route, and for 1.1.1.1, we now have two paths in the IP routing table. We only had one before. And by giving that variance command, it's also giving us a couple of ways to get to the loopback IP address of router R3. And that's how we configure unequal cost load balancing with EIGRP. We use the variance command. EIGRP has a feature called Auto Summary, and I want you to understand how it might be a good thing for your network or it might be a bad thing. With the Auto Summary feature, we can reduce the number of individual routes that we have to keep in our routing table, because EIGRP has the ability to summarize networks at their classful boundary using their natural mask. And while that can be a great thing for reducing the size of the IP routing table, if we have discontiguous networks that are part of the same classful network, that could cause an issue, and that's what we want to demonstrate here. Notice off of R2, we're directly connected to the 10.2.2.0/24 subnet. But what is the classful mask of this 10. Network? Well, the natural or the classful mask, it's an 8-bit mask. It's 255.0.0.0. And you'll notice that there's another 10. Network up at the top, 10.1.1.0/24. If R1 and R3 are advertising that network at the classful boundary, in other words, they're not advertising 10.1.1.0/24, they're advertising 10.0.0.0/8. If they advertise that and R2 receives that advertisement, R2 is going to say, I already know how to get to the 10.0.0.0/8 network. I'm connected to it at a fast Ethernet 0/0. And that's going to be more believable than anything I receive from R1 or R3. And as a result, R2 will not know how to get to this network. Let me prove it to you. Let's do a show IP route. And you'll notice that we do not know about the 10.1.1.0/24 network. We know about the IP address assigned to Fast Ethernet 0/0. We know about the network connected to Fast Ethernet 0/0, but we do not have an entry for 10.1.1.0/24. In fact, let's see what happens if I try to ping 10.1.1.1. That's the Fast Ethernet 0/1 interface on R1. It looks like our ping is failing. It's timing out. And that's because we don't know how to get there. Why don't we know how to get there? Well, let's go to R3 or R1 and we can do a show IP protocols. Since we were pinging the interface on R1, let's go there. Let's do a show IP protocols. And we can see that automatic summarization is enabled. And we are summarizing this 10.network. Here's the command that makes that happen. Let's do a show run pipe to section router EIGRP 100. The command that makes this happen is auto summary. And you might want to check your gear if it's running EIGRP and determine whether or not auto summary is enabled. I've got it enabled on all three of these routers, and because I've got these discontiguous subnets that are part of the 10.classful network, we're running into connectivity issues. Let's fix this by getting rid of the auto summary command on all of these routers. On R1, let's go into router EIGRP 100 and we'll simply say no auto summary. We'll go to router R2 and do the same thing. On router R2, let's go into global configuration mode and then into router EIGRP 100. No auto summary. One more router to go. Let's go to router R3. Router EIGRP 100. No auto summary. Now that we've removed auto summarization, let's go back to R1 real quick and do a show IP protocols. Now we don't have that message saying that we're summarizing the 10.network. Now if we go to router R2 and I do a show IP route, we should see that 10.1.1.0 subnet. There it is. We're preferring to get there via R3 because it's a faster link as compared to the serial link. It's got a lower metric, but we can now apparently reach this network. Let's double check. Let's do that ping once again to 10.1.1.1. And we have success. We are now able to reach that network because we're receiving variable length subnet mask or VLSM advertisements for that subnet as opposed to a classful network advertisement, which we pretty much ignored because we were already connected to the 10.0.0.0/8 classful network.